and welcome to another WJEC A level physics question. This time it's question 2 from May 2016's Unit 1, and it's effectively a projectiles type question. Starts off with a typical velocity time graph for a body which is accelerating. You can see on the graph that the body starts with an initial velocity u, finishes with a final velocity v and a time t. And using the symbols on the graph, we've got to show that v equals u plus at. So we've got to derive that equation basically using the graph. So what we're going to start with is the fact that the acceleration of the graph, a, is the gradient. And the gradient of the line is the change in y, which is v minus u, final velocity take away initial velocity, over the change in x, which is t minus 0, or just simply t. If we multiply both sides by t, we get at is v minus u, and finally if we add u to both sides, we will get the required v equals u plus at. You could probably go straight from the step of a equals v minus u over t to v equals u plus at, but because it's a show question, it's definitely worth showing an extra step in between. For the next part of the question, we've got a cannonball fired horizontally from the top of a cliff, and at the same instant the second cannonball is released and just falls vertically from the same initial height. And the second cannonball is shown at two positions during its descent. And the first part of the next part of the question is to draw on the diagram the expected positions of the fired cannonballs at the same time instances as the positions indicated by the drop cannonball. And we've got to explain our reasoning, ignoring air resistance. Well, both cannonballs have the same initial velocity of 0 in the vertical direction. We've got to be very careful here. So have the same initial vertical velocity of 0. They've got the same acceleration, the acceleration due to gravity. Let's put that in brackets. And they're falling for the same time. So basically they're going to be in the same vertical positions at the same time intervals. So let's say they will have fallen equal distances in the same time. So we can use that, if we go back to the diagram in a second, to draw the positions of the fired cannonball. We just simply want to make sure that it's near enough the same vertical height. Okay, next the cannonball is fired, impacts after 3.2 seconds, and we've got to calculate the height from which the cannonball is fired. Now with an equations of motion question like this, I like first of all to decide on the direction to be positive, and if something is falling downwards it makes sense to take the downward direction as positive. I also like my students to think very carefully about what part of the motion that they are looking at. So they're looking here from the maximum height down to ground level, and then I like them to take the 5 letters for our equations of motion and fill in what they know. So we've already said the initial vertical velocity is 0. Remember, this cannonball is fired horizontally, so it's not moving in a vertical direction. The final vertical velocity is an unknown. X is the height that we're trying to find. Acceleration is going to be a plus 9.81 meters per second squared because we define downwards as positive, and the time will be 3.20 seconds. For this part of the question, we're not actually interested in the final vertical velocity, so we're going to use the equation of motion that doesn't have final velocity in, which is x equals ut plus a half at squared. Now here u is 0, so ut is 0. And this equation then will simplify to x equals a half at squared. So now we can just substitute in figures. Half times the acceleration of 9.81 times 3.2 squared. And let's see what that gives us on the calculator. It gives us about 50 meters, 50.2 meters. I'll go for 3 significant figures here because both the acceleration and the time were given to 3 significant figures. For the next part of the question, we've got to calculate the velocity with which the fired cannonball impacts with the ground. So what we can do is we can use the information that we had in part 1 of this question to find the final vertical velocity using v equals u plus at. You could use a different equation if you wanted to, now that we know everything apart from v, but this is probably the easiest one to use anyway. So remember, the initial vertical velocity was 0, the acceleration is 9.81, and the time was 3.2 seconds. If we put those into the calculator, you'll end up with 31.4 meters per second. Now, I've seen weak students stop at this stage thinking that they've solved the question because they found a final velocity, but this is only the vertical part of the velocity of the cannonball when it hits the ground. The cannonball is also moving horizontally. So we're going to need to find the horizontal component of the velocity of the cannonball. And horizontally, since there's no acceleration, we simply use VH. In this case is x over t. Speed is distance over time, or if you prefer, velocity is displacement over time. If we go back to the diagram, we can see that there's 360 meters moved horizontally by the cannonball in the time of 3.2 seconds, and that comes out as 112.5 meters per second. And I'll leave it there with all those figures and do a little bit of rounding at the end. Next, we're going to add those two vectors vectorially. So horizontally, we got 31.4 meters per second. Vertically, and the diagram's not to scale, it's just a rough sketch, we got 112 meters per second, 112.5 meters per second. And the resultant velocity is the diagonal of this diagram. So v, as I've called it, will be the square root of 112.5 squared plus 31.4 squared. And when we put those into the calculator, we get to the three significant figures, 117 meters per second. Now, a lot of students would again finish at this stage, but we've got to remember that velocity is a vector. So I'm going to add an angle theta to the diagram here. To me, this makes the most sense because it's the angle between the initial velocity and the final velocity, and I'm going to calculate that using a bit of trigonometry. In the triangle, we've got an angle, we've got an opposite, and we've got an adjacent, so we can use tan. Tan of theta would be 112.5 over 31.4. So theta will be tan minus 1 of 112.5 over 31.4. Let me just cross that out, 31.4. And if we put those into our calculator, we get an answer of 74.4 degrees. If you put the angles or the velocities in the wrong way around and do 31.4 over 112.5, you get about 15.6 degrees, and what you would have actually found is that angle that I'll mark phi there. Nothing wrong with that, you can actually find that angle so long as you mark it on the diagram as the one that you're actually finding. But a little mental test here, if we're looking at the angle I marked as theta, this side is bigger than this side, so this angle must be the larger of these two angles. So the correct answer for the original theta that I've drawn must be 74.4. So thank you very much for listening. Please remember to like and subscribe, and feel free to leave any comments below. Goodbye.